Welcome to Mangan Software Solutions Safety Lifecycle Manager, SLM. This short video will show you how to use SLM to transform your process safety data into meaningful information. SLM combines multiple disciplines into one cloud-based solution, allowing you to share, access, maintain, and utilize safety data in a more collaborative way. With SLM, you can eliminate the need for multiple independent systems that require time-consuming manual data transfer. SLM was designed for engineers like you. It is made up of 12 configurable modules fit for purpose to help you manage the safety lifecycle more efficiently. So let's get started with the HAZOP module.
With SLM's dashboards, see your SIS lifecycle data how you want to see it. SLM's dynamic reporting system allows you to sort and build reports, dashboards, and KPIs on the fly. With a click of a button, download your data in the format you prefer. In the HAZOP module, you can easily find HAZOP studies that have been completed or are currently being worked on. You can also see the company risk matrix at multiple levels from different sites, different units, and even see the effects of your scenarios if certain IPLs are put into bypass. By moving over to the HAZOP studies, I can see all of the active HAZOP studies from different sites. So we'll take a look at this HAZOP. So this is the facilitation page where you can view different nodes, and for each node, you can see the related scenarios underneath. So for a node, you can see the PNIDs, the node types based off of the type of equipment that's associated, as well as the design intention. Each scenario, you can view the deviations, the cause likelihood, the related initiating cause frequency, the consequence, and the hazard risk. Based off the risk and the likelihood will give you a risk ranking. From there, you can identify different enabling events, barriers, and if those barriers are IPLs, you can put in the PFDs and apply them to the scenario. From there, you can also identify conditional modifiers, which will give you a result of whether you are meeting your target mitigated event likelihood based off of the IPLs and conditional modifiers that have been applied. For example, for this scenario here, we have a high pressure with a cause of an isolation valve and oil production malfunction, and a potential increase through the online flow line gives a severity of a 4, which is up to 3 fatalities. This makes the target mitigated event likelihood of 1e to the negative 4. So we currently do not have any modifiers applied, but we do have one SIL2 barrier. Now this is not enough to bring us to our initiating event likelihood of 0.4. So we'll need to either add another barrier or add a conditional modifier or enabling event. So if we add an enabling event here, and we have some pre-existing enabling events that are loaded into the global module, we can apply it. And now see we are meeting our target. At any time during your HAZOP facilitation, you can add a new node, add equipment to a node, or add deviations to nodes. You can also see a list of your different enabling events, a list of your barriers, a list of your conditional modifiers, and a list of your recommendations. You can also mark scenarios to come back to or add in parking lot items. If you have a scenario that has a gap and is not meeting its target mitigated event likelihood, then you can easily add a recommendation. Click the edit. You can either add a previously created recommendation or add a new one. Once your HAZOP is complete, you can submit it for approval. If you are an approving authority, you can either press self-approve, or if you're not, you can add an approver, and it'll give you a list of people that have been assigned as approvers for this unit for HAZOPs. Once the HAZOP is approved, the number of scenarios from that approved HAZOP will show up in the risk matrix. By simply clicking on it, you can see all of the scenarios that are related to that box. In the LOPA module, you'll be able to see the LOPA risk assessment matrix. This will show you how many scenarios fall within each box after the mitigations are applied. From here, I can also see the IPL registry. This will show me how many IPLs are taking credit for each of the different types. For example, if I look at SIL2, you'll be able to view the related barrier. For this example, we have a PSH will detect a high pressure. This is a SIL1 with a PFD of 0.1 and an assumed RRF of 10. The system will actually calculate the demand rate and the target RRF and SIL level based off of all of the scenarios it's related to. So this IPL is related to 2 scenarios, each having similar severities, and I can see a graphical representation of the initiating cause, the PFD of that SIF, the downstream IPLs, and the consequence of that event. I can also link this barrier to a function in the Instrumented Systems module. This is where I'll begin adding SRS information if it is a SIL related SIF, as well as completing the SIL calculations. The benefit of either importing your existing LOPA worksheets or facilitating your HAZOP and LOPA and SLM is you can do your LOPA rationalization. In one view, you can see all of the different scenarios, and of those scenarios, which scenarios have gaps, and you can identify whether that LOPA has been rationalized or not, which means checked against the HAZOP data and claimed IPLs effectively mitigate the scenario. In the Instrumented Systems module, we have a SIF Design Executive Summary Report. From there, you can select the site, unit, related HAZOP study, and LOPA study to generate a report. This report will print off in an Excel file that will show you a executive summary of all of the process subsystems, related SIL-rated IPLs, their allocation progress, RF verification progress, response time verification progress, and HFT verified progress. In the Instrumented Systems module, you can also print off the SIF Design SRS report for either a single SIF or multiple SIFs. Here is an example of the SRS report. In the Instrumented Systems module, you can view each subsystem. For each subsystem, you can view the applicable safety instrumented functions. For each safety instrumented function, you can identify whether they're 14C required, and you can view and fill out the verification checklist that eventually is reported on the executive summary. Each tab will have specific information in order to fill out the complete SRS. For example, this is a SIL1 SIF that has an RRF of 10 with a SIF response time of 2.4 seconds. I can view the SIL calculation by clicking on the SIL Calc Summary. In the SIL Calc Summary, I can view the graphical representation of what this SIF looks like. This has a 1 out of 1 input and a 1 out of 1 output with a 25-year overhaul. And I can see, utilizing the failure rates, that I am getting a total RRF of 110, which meets our requirement. For this SIF example, we can even see how far we can extend out our testing interval and still meet our target RRF by going to the IO sensitivity. So since the failure rate source that was used was the Shell PFD, I will continue to use that. With a 3-month input test interval and a 1-year output test interval, I can see that our target is 11, and as long as I stay above a 9-year output test interval, I will still be meeting my target RRF. Here I can see output test interval cannot go below 8 years, and I can extend my input test interval all the way out to 12 months. The Operate and Maintain module allows us to track information on the IPLs and devices once they are fully up and running. For example, we can see upcoming tests as well as overdue tests. We can also see bypass status if any of the IPLs are currently in bypass. The SLM platform can be integrated with your historian as well as your plant CMMS. We have 2 systems that are in active bypass. I can also see those bypasses that have been approved for authorization. In the Demand Summary tab, I can view the demand status for each function by type. For example, I can see for each SIF, for the units for each SIF, how many demands, how many have passed, how many failed, and the demand rate by service hours and installed hours. The Operate and Maintain also allows us to view KPIs, such as Tier 3 KPIs, which are challenges to safety systems. For each different IPL type, I can see how many are within the expected demand rate, how many are failing test, how many are failing to operate on demand, and what is the overall availability based off of how often they are bypassed. I can also see this information based on each equipment and the IPLs associated with those equipment. I can also identify bad actors. The system will identify the IPLs that are either that have the highest demand rate, or those that are failing tests, or failing to operate on demand, or have high spurious trip rates. SLM's powerful analytics transform SIS lifecycle and process safety metrics into leading indicators. This gives business leaders and engineers unprecedented visibility and ensures that process safety risk controls are being effectively managed before incidents occur.